All right, welcome back. We're going to be doing our favorite chicken lab. This is your first bivariate lab of the second part of the class. So open that up, definitely save and put your name. You want to have SAS open. Remember, you're going to put this in your file. If you don't remember, you're going to double click on favorite chicken. You're going to kind of scroll this part down here. You're going to put my folder. I called it fave underscore chick, and just save that and remember to run it. Okay, remember to run that. All right, cool. And what you might want to do is just go ahead and do a proc print, and that's going to allow you to see what is in here. So you did my folder, fave chick, and you're gonna go here and you're gonna run that, and you're gonna see some nice variables. The favorite part of the chicken, remember that's gonna be the breast, the thigh, the wing, leg, or other, and then just the sex, male and female. All right, and we're gonna go answer our first research question. Is there an association between sex and a person's favorite part of the chicken? Do you think there's an association? All right. Now remember, association means there is a difference in the part of the chicken between male and female, meaning men like different parts of the chicken and women like different parts. No association means that they're the same. Men and women like the same parts of the chicken equally. It's equally distributed. So what do you think? Go ahead and put that down there. All right. You're going to put it in your library like we just showed, and you're going to do a proc print, and you're going to print out your first 10 lines. Cool, no problem. All right, now we're going to look at what is my research question. All right, well, my research question was just right here. Is there an association between sex and a person's favorite part of the chicken? And I'll just put this here. All right, remember that there is what they call an explanatory and response variable. The explanatory variable explains why the response variable happened, or you can say the response variable is a response of the explanatory variable. So is a person's sex or gender, is that the explanatory? Does that explain the chicken that they like, or does the chicken, the favorite part of the chicken, explain their sex? All right, I'm going to let you put that there. Then you're going to put a what type. Obviously, these are both categorical um, variables, and this is what they call a categorical to categorical connection. So sometimes you might see, we might call it a cat to cat, and you'll see that. So whenever you have a cat to cat connection, there are certain variables that go with each one. All right. So in a bivariate table, what table should you use? Okay. The table we're going to be using is what we're calling a two-way table. All right. And so remember that, so you can have two variables and they will look perfect. All right. Well, to do that, to create a two-way table, all we need to do is use that famous proc freq, right, or proc frequency, because in essence you're making a frequency table, but you're doing it with both variables. Okay, so I'm just writing a note to myself, and I'm doing a two-way table, so I'm going to do proc freq, and I'm going to tell SAS where my data is, which is in my folder. All right, and I'm going to put table here, and I'm going to go here and look at my variables, which is fave part and this a person's sex. So let's do that here. All right. Now, I'm just going to run that. And when I run that, I did this on purpose. I have two nice frequency tables. All right. And I can see that the breast is the most popular. More women are in the survey. Um, However, about 200 people, we don't want that. We want a two-way table. So remember, you need to put an asterisk in the middle there. Okay. And so I'll run that, and we'll have a nice, beautiful frequency table here. However, you can see that there's a lot going on right there. Cool. And so we can put that here, and then we're going to clean it up. All right. So let's go ahead and clean this up. And remember to put a backslash here, and I'm going to put no column. That's no column to percents, no row, and then no percents. All right. And now we're going to be able to just see a nice cleaned up table right here. All right. And so I want you to look at that and say, okay, just look at it across. Is the male, female, the part of the chicken that they like, is that the same as males? If you look at wing, that looks the same. Thigh, pretty close. Other, pretty close. Leg, there's some difference there. In breast, there is some difference there. All right. However, we want to look at the percent. So if I'm looking across, that's the rows go across. So I'm going to take this out and look at the percents and see if those percents are close to the same. All right. So when I look at that, the percents of a male look pretty similar. They're off a little bit. We don't know if they're statistically different, but we want you to see that. So from there, I want you to answer the question based on the table. Does there seem to be an association between the two variables? Remember, association means there is a difference. The two, male and female, are different parts, like different parts of the chicken. No association mean male and female. The parts of the chicken they like are the same. All right, so now we're going to a bivariate graph because we got a table, and now we got to go to the graph. All right, and so the graph that we're going to be looking at is what we call the mosaic plot. All right, the mosaic plot, and that's going to put two things together and make it look good so we can see kind of like tiles and see how they look. So we looked at the percentages. Now let's look at the mosaic plot. All right. So the good thing about the mosaic plot, it's all coming from proc frequency. All right. So if I tell myself that this is going to be the mosaic plot, all right, uh, all I need to do is copy this down. All right, I'm just making sure that I spelled that correctly. AI, yes, cool. So I just need to over here type in the word plots, and if I type plots, all of these different plots, I'm gonna find the mosaic plot here. All right, and I'm gonna run that. Okay, cool. I'm running that, and when I go here, I have a beautiful mosaic plot here. And I can look at the columns, I can look at it across. All right, we can see that more females prefer the breast, more males and female, the wing is almost 50-50 right here. And there's a little bit difference here. So we want to see, do these columns or rows look different? You be the judge of that. I want you to put your answer down here. Based on the graph, does there seem to be an association between the two variables? All right, cool. So now we need to see if there is a statistical difference. Okay, we've looked the eye test, but we can't go about what we see. We just want to look at that to make predictions. The test that we're going to be using is called the chi-squared test. Okay, so this is the chi-squared test for association. All right, now does it look like chi-squared? Yes, it does. You don't say chi, you say the chi-squared test for association. All right, if you say anything else, then you make me look bad. You don't go to Harvard, you don't go to Stanford and say the chi-squared test. That makes me look stupid. All right, cool. So basically, the chi-square test for association tests to see if there is an association or not. Okay, so we'll just put this here. All right, and the hypotheses are very simple. All right, the null is there is no association. So remember, you have to prove association between sex and favorite part of the chicken. Okay, all right, there is no association between sex and the favorite part of the chicken. All right, the alternative hypothesis is the opposite. There is an association between sex and the favorite part of the chicken. All right, and we're going to work to prove that. And so you guys can do what you need to do. You can put some color on it. You can make it look fancy. Put some pizzazz. Put some stank on it. Make it look nice. All right, cool. Either or. The good thing about this is when I'm doing my chi-square test for association, it's literally going to be based out of proc frequency again. All right, so I just copy and paste that. I go to the end of proc freq and I find the chi-square test right there. Cool, and I'm just going to run that. All right, and once I run that, I just scroll down, and here you can see I have about 3 chi-square tests. The first one is this one right here. Okay, these are my p-value right here, 0.7765. Other p-value 0.7761. This one here 0.2550. We usually just choose the first one. That's my p-value. So I want you to take a picture here, and I want you to make a decision based on a p-value. What happens? What do you do when you get a p-value? What do you compare it with? You should know that already. Okay? And you're going to make your decision because my p-value is blank or greater than or less than the alpha level. Therefore, we do this. And tell me, what does that mean, right? Come back, put your two-way table here, put your statistical test here, and mosaic plot. And I want to show you that all of these should be working together. All right, they should say all the same thing. All right, I want you to finish that up, put that in. Have a great day. As they say in Hawaii, aloha.